And hello, everybody. My name is Josh Levent. I am a student in economics and computational economics in particular. I'm very interested in creating simulations of the economy. I have a vision that we will create a digital twin, a digital copy of the economy that is simplified, of course, but that simulates in some detail the real going-ons in the economy. And with that, we'll be able to study the economy much better. We'll be able to create virtual experiments in our simulated economy. And we'll be also be able to do better forecasts than what we have right now. So there's a certain kind of fundamental undecidability, I think, about the future of economics because of the nature of human creativity. We cannot predict what individuals will do. And since the economy is made up of individuals, we cannot predict exactly what will happen. But by having good economic simulations, we can create scenarios and create plausible pictures of what the future might hold. And we can create forecasts that will be better than forecasts we have today. So that's my vision, and that's why I'm interested in this and why I'm teaching myself how to do this. I'm learning economics at the moment, and I'm using this software, which I learned a couple of weeks ago at a summer school at the Scuola Superiore Santa Anna in Pisa, where there's world-class experts working on this kind of stuff. And I'm just sharing my journey here with you. So thanks for being here, and let's go right into it. If you haven't seen the last video, in the last video I created the level 1 simulation, which only had these three components. It had GDP, GDP growth, and GDP growth rate. Now the idea is with this tool to create an agent-based simulation. Right now I don't have any agents. I've just got these kind of macro features, and later we're going to bring some agents into it. But that's going to take a little bit more time because I need to add a little bit more structure, a little bit more environment, let's say, before there can be agents behaving in that environment. And so, today we're going to add potential GDP. I've just kind of made some notes for myself, and I've added some notation as well. So GDP here is, always T stands for the time step. At every time step, GDP is calculated as the sum of the previous period's GDP plus the change in the GDP. So this Y dot T represents the change in GDP from period T minus 1 to period T. And that's defined as the previous period GDP multiplied by the GDP growth rate of this period. And the GDP growth rate in every period is a random variable, which can be written like this, or as I've now done it in the code. Oops. 0, 3, and I can get rid of this part. Doesn't really matter. So that first parameter just gives me the center of this distribution. And at the moment I'm using this Cauchy distribution. What I've added here since last time also is this parameter for the Cauchy distribution, so I don't need to recompile my model every time I want to change this parameter. At the moment I've set it to 0.001. I think at the end of the last video I was playing around with some larger values, which caused some quite significant disruptions. With the smaller value it looks a bit more realistic. I found some empirical work also trying to estimate what the GDP growth rate looks like. In the long term, it doesn't matter that much for my simulation because we're going to try and make this endogenous out of the behavior of the agents. But still, it's quite interesting to think about what does that distribution look like. And there's some papers around that, globally across countries, it does look like a Cauchy distribution or like a Laplace distribution. There's a lot of literature, I think, estimating it in terms of a Laplace distribution. There is one paper looking at it in terms of a I don't remember the name, but another distribution which approximates a Laplace under certain conditions. But in any case, that distribution I couldn't find as a kind of pre-made one here, so I thought I'm not going to overcomplicate this. As I said, later this will become endogenous to the behavior of the agents. That means this growth rate will pop out of will be a result of our simulation and not something we code into it. But yeah, for now I'm happy with this Cauchy distribution, which is a fat tail distribution. It creates more kind of realistic behavior than just a normal distribution. And so today I'm adding to this potential GDP, which actually looks identical to the GDP thing here, and then to connect these two, I'm adding the output gap. So the output gap is just the difference, the rate between the two. So this is kind of approximated as the log of GDP minus the log of potential GDP. So yeah, we're going to go ahead and start just coding this in, and then we can let it run and see what happens. So I'm just going to copy all of this, and we're just going to put potential in front of all of these. And that is going to be those first three new equations done quite rapidly here. We only need one Cauchy parameter, I think. And now we need to add the output gap. And the output gap is, of course, an equation that I need to add here. And I've prepared myself the code here already. We're just going to call this the output gap. And yes, we're going to use this variable, temporary variable, to store this, which is exactly what I've written over here. It's log GDP. Oh yeah, not quite exactly actually. Minus log potential GDP. This is how I would do it if I was using Python or something like that. But result. So result, that's a keyword from LSD. I was a bit confused last time and tried to write return. That's not what we are doing here. We're giving the result of this equation. Okay, so yeah, the syntax needs to be adjusted to this syntax. So we just, oops, that's not what I wanted to do. This needs to go in brackets, as well as this. And then we put the v around it to tell it to call that variable. And since in this case, we're calling the variable of the current time step, we don't need to do anything else. So if we would want to lag it, we would need to use this VL macro, but I think that's enough. And so yeah, I think that's it. So this is a variable, and so are these other three, and then the Cauchy, that's a parameter, which is new since the last video. So I'm going to compile this, see if that compiles. Woohoo, compiles without error. That is always good. And so what I did in the meantime is I added this Cauchy parameter. I'm just going to delete it so I can show you how to add this parameter. So we're going to add the variables like we did last time. We have the output gap. We have potential GDP with a lag and an initial value, which I'm going to set in a second. The potential GDP growth and the potential GDP growth rate. And this one needs an initial value, which will be the same as the real GDP. And now I'm going to graph all of these as well. F6. Okay, and then, yes, parameters are added right next to the variables. The same as with the variables, it discovers any variables that have been defined inside other things but don't have their own equation, and then it thinks this must be a parameter, so it suggests it here. And so I can add it, and I have the parameter. And that is all I need to do for a parameter, except, of course, also set the initial value. In this case, it's I set it to 0.0. Hold on. It's funny because here it has something. It's saved somewhere in the configuration file, but here there's nothing. So yes, I'm going to save that. Control S. Not Command S on a Mac, unfortunately. And now I can run the simulation. I'm just going to check I was playing around with doing a different number of runs. I'm going to put that seed as something random. But we're just going to do one run, just see if it works. Okay, seems to work fine. So what do we have? GDP, potential GDP is down here for some reason. And then I think I'm just going to reset it and then take out, let's see, we're just going to look at the growth rate. Or what should we look at? Let's just look at that's not what I wanted. Let's just look at the growth in absolute terms. Yeah, so for some reason GDP growth is much lower than potential GDP growth. Is that now just, it could be just a matter of the seed. So I'm going to try changing the seed. No, potential GDP is greater, so I must have made a mistake here. That's quite strange. I mean, I copied this over exactly. Quite strange. Okay, this gives me a chance to show something I wanted to show, which is the Monte Carlo simulation. So one of the big aspects of this approach of doing these simulations is that you can do Monte Carlo simulations, which means you run this simulation many times and then you compare the results over many runs. And so I'm going to do that. I'm going to run it, let's say 100 times. And what we want to see is that these things are similar. Now, maybe it's because of the Cauchy distribution that we don't tend to see so much similarity, because these two, yeah, they're not well behaved. So we'll see if that continues to be a problem, then we may solve it that way. So I'm just gonna run it 100 times now. It's gonna, I think all these settings are fine as they are in default. Except I think I did the wrong thing now. An error occurred. Interesting. The error occurred in simulation 29, so this is not a general error. This is just because the Laplace distribution gave something silly as a result. So hold on, we're gonna I'm gonna just stop there. Anyway, I did this wrong, because if I do it this way, I think I don't get the results correctly. I need to do a parallel run, but we're going to change the seed to something else. It's a parallel run, and then it will run them all on my 8 cores at the same time, which is even faster than that's done already. Okay, and then now I can pull up this analysis window, and if I press add, I can press the files from the Monte Carlo experiment. So now it gives me the chance to take various metrics. I think I'm just going to take average, median, maximum, and minimum. The confidence interval, I think, doesn't make that much sense with the Cauchy distribution. It's a bit weird, I noticed before. So okay, something went wrong now. It's supposed to just, yeah, that's not working. It normally takes much longer, so I don't know what's going on here. Let me check actually. Let me close this. I am saving all of these. I'm gonna save this one too, actually, because it will be funny to see what this produces. Okay, let's see. Change the parallel run. Oh, okay. I know what the problem is. It's given me an error actually, and that's why it says equation not found for variable output gap, which is weird because there is a variable output gap. Now, let's see. Does the output gap need a lag? It's weird actually, because it was working fine running it one at a time. So you can also pull up the equations like this. Maybe I need to what does that mean? Oh yeah, I can introduce a delay. But I'm just calculating this at every period. We're just gonna put a lag in, I think. Wherever we put those in. Properties, lag. Let's see if that helps. Equation not found for variable output. I'm just going to bring over my log here. So yeah, it's quite strange. Equation not found. Okay. Oh, hold on, wait. This was the was this run now? So confused. Let me change the seed. Change it to 1. what is going on? Why is the C 211? Did I set the... Oh yeah, they have to press yes there and then... So... Yeah, that was... Okay. The variable has not been initialized. I see. So we need to have an... Right, if it has a lag, it doesn't need to be initialized. So the upper cap starts at 0. Yeah, now it's initialized. Okay, try that again. Equation, now it goes back to equation not found. Error. Oh dear. Actually had a similar problem when we were learning this, and I can't remember now what the solution was. There's something about something about changing some setting here. Let me just turn off the saving and turn off the run plot. And funnily, so I think this is only a problem when I run it in batch, because I think if I run it once, it works fine, right? So yeah, there's something about it might actually be a Mac thing, so because when you run it in batch, it like recompiles it into a different thing. And oh, wait a second, but it didn't actually do the compilation, so maybe I need to recompile. Huh. Okay, I think I'm gonna stop it here, and I'm gonna figure out the problem, and then I'm gonna continue this simulation